presenter is actually Philip. So we decided to swap roles now, and I'll chair and he presents. And Philip is gonna expand a bit more on the stuff we talked about this morning about route aggregation and the CIDR report. And I don't think we send them to the MENOG list, right? But they are circled on, for instance, the routing working group, RIPE and NANOG and some others. So if you're subscribed to one of these lists, you probably see the weekly email coming in saying, here's your BGP route table report and here's the CIDR report. And my guess is that Philip is going to explain all what it's about and how to make sure that you don't pop up being number one on deaggregation. If you get the presentation to work. Yeah. That is.
No problems.
Okay. There we go. Okay. Oh, floor is yours.
So good afternoon. This is probably the worst presentation slot because it's right after lunchtime and you still have lunch in your mind and so forth. But anyway, so I've been doing this for a few years. I don't think I've presented this at MENOG before, but it's really been a bit of a hobby of mine, as you probably got a hint from this morning. And it's just really tracking the size of the BGP table, what's causing it, and so forth, and spending a bit of time looking at the deaggregation that's taking place in the BGP table as well. So in 1998, that's when I started doing this. Nobody was publishing any internet routing table analysis. There was the CIDR report. The CIDR report, as I said this morning, started by Tony Bates when he was at the RIPE NCC, really to report on the top 20 contributors to the routing table. It was there to encourage network operators to convert their blocks of Class Cs into single announcements. So if they had 32 Class Cs, they could announce it as a 19, or 16 Class Cs, they could announce it as a 20, and so forth. 1998 was the time I joined Cisco, and with me moving from the UK to Australia to live, I got quite a bit interested in what was going on outside Europe, as you tend to do, and what was happening in Asia. If you look at the CIDR report, back then the top 20 contributors tended to be the top 20 North American and European network operators. Nobody really saw what was going on in Asia, or the Pacific, or the Middle East, or Africa, or Latin America, because the contributors to the routing table there were quite small. But I was pretty sure that they were still contributing sizable amounts. And so, well, this is part of the email report that goes out. Actually, it is sent to the MENOG mailing list. I've been doing that for a few years now. So I thought, well, I'll just grab some of this out here, and hopefully this has got a pointy thing. Does that produce light? Yeah, that sort of produces light. So 19th of September, a few days ago, 467,000 prefixes in the view that I have. APIA supports me in doing this in that they give me access to their router in Japan. So this is a router at Dixie, which is one of the exchange points in Japan. 467,000 prefixes here. One thing I do in this report that I run is I take the BGP table and work out what it could be if every ISP aggregated. And if every ISP aggregated, it would end up being 188,000 prefixes. So that is 280,000 prefixes that are of no earthly use whatsoever. And just so that I was able to prove that this still works, I actually set up a BGP filter that only allowed these 188 or whatever when I tried it, only allowed the aggregated table into my home router, and I still could see the internet and everything still worked. So the 280,000 prefixes that are junk. And so I'll just work out the deaggregation factor, 2.48, so the BGP table is 2.4 times bigger than it absolutely needs to be for you to see the whole internet. And there are heaps of other things. You know, when I started doing this report was very small, just a few lines. And because I sent it to various mailing lists, other operators then would say, oh, Philip, can you add? So I've added in a lot of other can you adds. So it's things like maximum AS path length visible, 30. So 30 ASs in the path is the longest. Maximum AS path prepend somebody's done, that's AS 36992, has done a 22 times prepend. Given the internet is not 22 ASs deep, I'm not quite sure what they're trying to achieve. I suspect these are folks who believe that if they do enough prepends on a /24, it'll become less and less important than the covering aggregate. That's usually the reason. 32-bit ASNs allocated by the registries, there are 5,000 of those, of which we see about 4,000 in the routing table. This is quite entertaining as well because we've got a lot of ISPs who say that 32-bit AS numbers don't work. Well, if they don't work, how come these 5,000 have been handed out and 4,000 actually visible? Certainly if you go around the Asia-Pacific region, most of APNIC's 32-bit ASNs have been handed out in New Zealand. Nobody else seems to want to use them, or they keep handing them back to APNIC to get 16-bit ASNs. News for them, there are only 500 left. So for the old 16-bit ASNs have just about all gone. So all these people who claim that 32-bit ASNs don't work will need to start figuring out how to make them work very, very soon. Anything interesting here? RIPE NCC service region I've picked out. Yeah, well, I'll jump over this, 120,000 prefixes. As ever, the aggregation within RIPE NCC service region is very good. It's always been under 2. So when I started doing this, it was about 1.3, 1.4. So it's certainly this part of the world has always been very good as far as aggregation comes. If we look at the global contributors, so these are the top contributors to the global BGP table. So Net Servicios de Comunicados SA, I think they're from Mexico, 3,271 prefixes. So they're the biggest provider biggest contributors to the BGP table. So everything in red is under LACNIC's region. Everything in green is Afrinic, so Sudan Mobile Telephone Company is announcing quite a heap of prefixes as well. This column is the one that I keep going on about. This is the column that if that operator bothered to do some aggregation, it's what the actual contribution would be, right? So Sudan Mobile Telephone announcing 1,864 prefixes. If they aggregated, they would then end up announcing 5. The downside is the marketing department will get really upset because they don't appear in the top 20 or whatever in this list. That seems to be a lot of the reasoning. But if you look through this, you can see some of the spectacular savings that are possible. You know, there's a Russian ISP here. 1,746 can be aggregated down to 16. BSNL in India, 1,535 could be aggregated down to 40. Global Village, 1,432 could be aggregated down to 20. So I'll come back to these. There's some quite spectacular ones in the list. Just looking at the size of the different prefix announcements, this is my view, but look at the /24s. We've gone up from 192,000 2 years ago to 247,000 now. There are more /24s in the BGP table than any other prefix size. So I think that's quite clear where we're all going with the /24s as the lowest common denominator. Some of you are probably thinking, what's happening in IPv6? Well, guess what? /48 in v6 is becoming the /24 in v4. If you look at the v6 BGP table, which I'm not doing here, it's just under 50% of the announcements in the v6 table are /48s. Again, a lot of providers are taking the 32s and chopping them up into little pieces, /48s. Well, the only victor from that is going to be the vendor, the router vendor selling you gigs of memory of your routers, because there are a lot of 48s in v6. I look at prefixes smaller than the registry allocation. So the registries have all published the minimum allocation size. So in theory, you shouldn't see anything smaller than that apart from people doing traffic engineering. Well, that's not the case. You know. For COVID, 2016 of their announcements are smaller than the minimum allocation that Aaron has ever made. compared with 2,065 total announcements, and so on. We go through the list. BGP routing table, onwards and upwards. I mean, this is since I started in 1999. But you see, it's gone up pretty well. Here was the dot-com crash, 2001, and then it was kind of took 3-4 years to recover. Before, about 3 years ago, the increases steepened again. I think I've got the graph lines here. Whoops. All right, so you can see that the routing table growth until about 3 years ago was reasonably steady. And then about 3 years ago, about 2.5 maybe, it took off. It steepened. That coincided with IANA running out of v4 address space and APNIC running out of, well, going into the final /8 a couple of months later. So that's contributed to the increase in the routing table growth. AS growth has been pretty even. Whoops, what's going on here? It's been even. The interesting thing here, that's when the router was upgraded to support 32-bit AS numbers. And then it was like, oh, all these AS 2, 3, 4, 5, 6s, which are the transition AS, suddenly became real AS numbers. So we had a little step there. Maximum aggregation versus unique prefixes. So the yellow is the BGP table today. Blue line is where it would be if everybody aggregated as severely as they could. So notice how the aggregated BGP table is starting to tail off. That, again, is caused by the v4 runout, whereas the actual BGP table is actually getting steeper and steeper. So the prediction of an accelerating v4 BGP table seems to be coming to pass. Prefix sizes announced, well, I don't know if that's really interesting. /22s are going up quickly. Notice that, how /22s have kind of taken off. That's the maximum address space you can get as a one-off from APNIC and the RIPE NCC now out of the final /8 policy. So that's contributed to the /22s going up quite steeply. What we're finding in the Asia-Pacific region is that ISPs who no longer have enough address space to delegate to their customers are telling their customers, go to APNIC, get a /22 from there. So actually, the registry is getting more /22s out to end operators rather than being delegated through ISPs. The /24 is announced, I mean, the usual thing, more than half the table is /24. Address space announced, well, again, when IANA ran out, it started tailing off because, well, APNIC and more recently RIPE NCC didn't have address space to hand out generously anymore. And you can see the growth curves there. It's all tailed off in the last year or so. AS announcements. So the blue line just shows the total ASNs being announced. The light blue one there, if you can see it, are the origin-only ASs. In other words, network operators or infrastructure providers who are at the end, who are providing access to the end user. So that's the vast majority of ASNs. The yellow line here are operators who provide transit as well as originating prefixes. So it's your typical medium-sized ISP who's providing transit to end ISPs and end organizations. And then this one at the bottom, which you can't see, the red line, are providers who are giving you transit only. There are only about 170 of those. Maximum AS path length is quite amusing. Every now and then, you've got somebody who does some stupidly long prepend. I don't know. I think the router may have a limit of 150 or something like that for the max AS path length it can get. But you know, some of these where it peaked up to 255 and then it caused bugs in iOS and Junos and so forth. But generally, you see the AS path, maximum AS path length that I'm recording. You see an increasing trend there, which I find a bit curious, especially when the internet is not very deep as far as autonomous systems go. Growth in v4 address space allocations, well, obviously, we've run out. But that little blip there was when IANA got some address space back and reported it as such, so it appeared as a 99.9% usage. There were was a couple of /16 or something appeared in the IANA list, so I picked them up there. Prefixes per AS number, that one's a bit intriguing. It's the number of prefixes being announced on average by each autonomous system. So in the early internet days, well, early as in 99, quite a large number of prefixes per autonomous system, and then it minimized around about 2005, and then it's crept all the way back up, so it's running about 10.5 prefixes per ASN. Is this caused by deaggregation or what? I don't really know. Given the internet here wasn't very aggregated at all, was very aggregated, but there weren't very many autonomous systems compared with now a large number of ASs. The graph is creeping back upwards. Anyway, so those are just some of the things I'm measuring. There's a whole heap more. Now, just looking at deaggregation a little bit more, the CIDR report was really looking at how many ISPs were still using or doing making classful announcements following the deployment of classless routing. So how many were making these classful announcements? So that's what it was started for. So Tony Bates ran that when he was just, I think, at the end of his tenure at the RIPE NCC before moving on to Internet MCI. And he ran that report all the time through his Cisco days and so forth. I had a go at it for a while. Jeff Houston had a go at it and is now running most of it. Hence, it's got a nice website and a detailed amount of reporting with it. I did the routing table report because Tony's report was a global view. I wanted to look at within each registry region. And so one of the things I worked out was this deaggregation factor, which looks at the BGP table as well as the maximally possible aggregated version. So just looking at it, global table 468,000, global average 2.48, Europe, Middle East, North America, around about 2 as a deaggregation factor, which to me seems pretty reasonable. To me, it sounds, yeah, that's typical for a network operator who's announcing aggregates and needs to do traffic engineering through multiple upstream or peers. It's when you go into Asia-Pacific region, Africa, and Latin America that things rapidly fall to pieces. And that's generally been my experience as well, that the understanding of what IGP versus IBGP versus EBGP simply doesn't exist. Or if it does exist, it's really not used. The typical thing I see through a lot of Asia is, oh yeah, I've got all my customers in IBGP. We don't have any EBGP filters at all. We just send our IBGP out to the world. And yeah, it all works fine, so let's go and do that. That's very common. And so for all the training and everything else we do, operators don't get that announcing a covering aggregate is probably the better thing to be doing. So it has an impact on the BGP table. Even though the biggest announcements are not from these 3 regions, they have a bigger impact than the other 2. So that's what it looks like graphically. So the yellow line is the global one. So as I was saying earlier, it was about 1.3 globally when I started. And the blue line here is, well, the APIA region. Hang on, but which one am I looking for? RIPE NCC region. Notice right down here it was about 1.2. It was very, very well aggregated. And it's crept up to about 2. So just under 2. So certainly if you look at ARIN region and RIPE NCC service region, it's generally been pretty well behaved and it's reflected in the global average. But you look at the other 3, it's certainly quite dramatic. The lines start here because that's when the registries came into existence. It's not that I didn't have data before. That's when AFRINIC and LACNIC started. But if you look at the savings that are possible, so if I've just taken the ASs within the RIPE NCC service region, and these are the top, I think it's the top 20 savings which are possible. So these operators, for example, VimpelCom here could take the 1,746 prefixes and aggregate 1,730 of them. And they would only have 16 announcements left in the BGP table. That would be a significant saving. By the time you add all these up, you come up to the 280,000 prefixes I was mentioning. But we can run through the list here. I'm not going to read them all out. Are there any well-known names? Are there any names from this part of the world? Well, if you're there, you'll recognize yourself. But just for entertainment, and please don't throw things at me, I did some for this part of the world. So Kuwait, I've picked out the top 10 in Kuwait. So again, just looking at some of the ASs here, what they're announcing, and the savings that could be made. So these are, if they did aggregation properly, the announcements made would be reduced by this number. I've done the same for UAE. So again, you get the idea there, the amount of savings. So Emirates Telecoms, for example, 205 announcements could save 182. Dubai Internet City, 136, could save 125. Jordan, I did Jordan as well. Jordan Datacom, 181 announcements, 170 savings. VTEL Holdings, 9 announcements, 8 savings, and so on. You get the idea. For Saudi Arabia, same sort of idea, going through some of the autonomous systems there. Right, so I've picked some examples from the MENOG region just to show the typical deaggregation that's going on and what could be done, what improvements could be made. Size of routing table, well, a lot of people, after I've given this presentation, say, well, you know, it's not a problem. I can go to Cisco, I can get 4 gig of RAM or 16 gig of RAM or whatever. I know, yeah, my network's carrying 2 or 3 million prefixes. I've got all this MPLS, and I'm doing provider work, and I've got all these prefixes, and it's all working fine. What are you talking about? This doesn't matter anymore. Well, I suppose it doesn't really matter. I mean, we're seeing routers now with 64-bit operating systems. So in theory, we could just keep adding memory and adding prefixes to the routing system. Of more concern is the actual convergence of the routing system as well. I mean, we really are in uncharted territories. And what's interesting, even though with the routing system growing bigger and bigger, we don't seem to have had any of the instabilities. At least, I remember the instabilities in 94, 95, before route flap damping was introduced. And those were pretty severe compared with what we're seeing today. And because, you know, the internet then was much smaller, we're only talking a few thousand prefixes, and it took one provider in the US to flap just a few hundred /24s to cause the whole internet to be unstable. But, you know, Jeff Houston, as part of his CIDR report work, also started looking at the BGP stability or the instability. He's now running an instability report. I don't know if it's posted anywhere. It might be posted to MENOG list. I don't know if it's posted to MENOG. Is it posted to MENOG? No, I think it goes to MENOG. I don't think it comes here. But it's pretty interesting as well, and I've put on a couple of slides with that. And this looks at the 50 most active autonomous systems for the past 7 days. You can't read the slide here, and you definitely won't be able to see it on the webcast, but go to the URL. So the most unstable autonomous system in the world is 9829, which is BSNL, the national internet backbone for India. They're giving Jeff's view 51,000 updates in 7 days. And you think, well, you know, 51,000 updates, that's quite a few. Well, 10,000 updates in 7 days is 1 update per minute. So they're sending 1 update from their AS every 12 seconds. Your router is seeing the update. I mean, if you got the full BGP table, you are more than likely seeing the update. I mean, Jeff is not connected directly to BSNL. He's a few AS hops away. So you will be seeing the same type of thing. You go through the list. In fact, everybody on this page here is generating more than 1 update per minute, and your routers are hearing it. So, you know, we've got this Russian provider again, Oops Telecom. Well, it seems appropriate name somehow, but... and then we've got Sudan, the mobile company in Sudan. We've got Bharti here, another Indian ISP. And so on, we go through the list. So these are the unstable ASNs that are all hitting your router. Looking at the actual prefixes, you know, we can look at these. Now, generally, you would think that it's /24s would be the most unstable prefixes. That tends to be the smallest that you can get past BGP filters of most providers. But you look through the list, and it's not all 24s. The most unstable one is this /20 coming from Yar Telecom, Rostelecom. Sounds like Russia to me again. 1 update every 30 seconds. Every 30 seconds, this /20 is coming and going, coming and going. I'm not quite sure what a customer on the end of that /20 is going to experience, but it doesn't feel very good. /21 here, another 21 here from Hoshin Multimedia Center. We've got, what else? We've got a 21 there. We've got a 17, half an old Class B, bouncing around by liquid web. Yep, very liquid web that must be, given that particular instability. So this is the one, it's quite interesting to watch. Hopefully somebody at the RIPE NCC can explain this one, 84.205.66/24. Maybe that's meant to be bouncing on purpose, I don't know. But it's seen to be bouncing quite a bit by Jeff. Well, it's, I don't know, AS12654. So that's the instability report that Jeff is doing. But this is, again, this is concerning for quite a few operators. Certainly the backbone providers are seeing these BGP announcements. I mean, you look at this. This is 2% of all updates coming into the router are caused by this one particular autonomous system. I mean, I mentioned Sean Duran this morning. I don't think we have a Sean Duran type person left running any network backbone operating provider. But you know, these sort of behaviors are probably things that would tempt some operators to go, why do these people keep beating up my router like this? You know, I didn't ask them to send all this instability, so why do I actually allow it into my network? Anyway, observations, range of operational practices between registry regions, deaggregation by newer providers, developing regions is very significant, I'm seeing more instability in the APIA, LACNIC and AFRINIC regions than I'm seeing anywhere else. But the thing is, they're visible over the entire internet. They're not just visible locally for the providers causing the instability. Everybody actually sees them. This RIPE 399, that's the recommendation. There, of course, there's the V6 version, which I forgot to add to the slides. And that, again, it shows the industry expectation of you get address space from the registry, how you're meant to announce it. So, in other words, announce your aggregate, announce sub-prefixes to help with traffic engineering. Be nice to the internet, because you're part of it. It's not something that you connect to. And of course, the hope here that registries will include pointers with each address allocation. I mean, I certainly know APINIC does, but hopefully there's a pointer that says, have a read of RIPE 399, have a read of RIPE 56, whatever it was. Hopefully that more folks will pay attention to it. Training is there. And what I find, a lot of people choose to ignore a lot of the best practices that have been learned the hard way over the last 20 years. That was it. Are there any questions at all?
Anybody?
It's here for helpful advice. I'm not criticizing any operator or anything like that at all. So it's just here to try and encourage folks to look at what they're announcing and hopefully try and make things a little bit better.
My name is Samir. How do you convince ISPs to aggregate when they are using the tactic of breaking down the network for traffic engineering?
Well, yes. I mean, the argument has always been traffic engineering. And certainly for most operators, the larger operators I have worked with, traffic engineering needs a few prefixes. It doesn't need, you don't need to take, say, a /10 and chop it into 24s. I've found, as certainly in the newer ISPs, their method of traffic engineering has always been the shotgun approach. They take their aggregate that they have, they chop it up into 24s, and that's all they do. They don't do any engineering. And you know, if we all did that, the internet wouldn't work. It simply would not work. And this was certainly one of the issues that certainly some of the European and North American ISPs have been doing over the years, is looking for ways, if they see people announcing an aggregate, announcing heaps of 24s, they just put filters in blocking it. Certainly during my Cisco days, there were certainly a lot of feature requests from major providers. Can you put an auto-aggregation command in? So you do neighbor BGP something or other, auto-aggregate, which would, if somebody was announcing a sub-prefix, it would be automatically dropped. But you know, how you would implement that and how you would not break valid traffic engineering has always been a very good question. What I've done over the years and what many colleagues in the industry have done is offered our time for free to just come and have a look and see why the traffic engineering? You know, if people need to chop, say, a 19 into 32 24s, why they need to do that? And we've rarely found any provider who's needed to do that at all. And I didn't put examples here, but you know, there's some spectacular examples where people have literally taken like a 16 or a 15 or a 14, chopped it up into 24s. One example was the argument was, oh, our management has told us we've got to announce 24s because they're afraid that another provider would announce the 24s as well and do a DOS attack, you know, as Marco was describing before lunch. But the reality of that happening, I don't think that's really happened, and you know, there are a lot of safeguards in place to prevent that. So there are all these kind of strange arguments, which on the face of it don't make a lot of sense. But certainly over the years, there've been many of us in the industry who have said, look, you know, we're quite happy to look at configurations. When I was at Cisco, colleagues in Cisco would sit down with some of the biggest offenders here. I mean, I think the best example I've seen was ChinaNet, which was frequently #1 in the deaggregation list, and they don't even appear in the top 20 now, or they're not even the top 15, because they made a concerted effort to actually figure out the traffic engineering, rather than just taking the APINIC address space, and they've got like /8 or something, and chopping it up into little pieces. But it takes a lot of work to do that, and you know, it's not just, you can't just wave any magic wand to try and do it. But I never remember this saying, it was what, you know, be generous with what you accept, and
Pastel's law.
yes, John Pastel's law. Generous
be
what
liberal
you accept,
in what to
liberal
in what to accept, and conservative in what to send out.
Yeah, but you know, it's very hard. That's the goal of this. But you know, it does take work to do it. So I hope that helps. There's no simple answer, but you know, there are several of us in the industry who are willing to help, willing to try and make a difference, if folks are interested.
Jan?
Okay, Jan-Georges, I have 3 questions.
Uh-oh.
Okay, so
you're stealing your own time, you know.
First
that, right?
one, there is IPv6 BGP report, right?
Jeff does a V6 CIDR report. Yes, I haven't done V6 of this one yet.
But you're working on it, right?
I've been working on it for 5 years.
Okay, there we go. So, okay, next question is, when you say aggregation savings, you aggregate based on the same AS path, or you don't care about...
Origin AS. So this is the best possible aggregation.
So you discard the traffic engineering and you just say this could be done if announced properly without traffic engineering.
Yeah.
Okay. The third question is, some people deaggregate because they just simply don't know how to do it better. Some people deaggregate because they want to do the traffic engineering, and some people deaggregate out of a fear for their prefix to be hijacked. So they announce the most specific, the smallest one possible. So what's the ratio between those ones that had no idea and those who traffic engineers and those who just have the fear?
Most of them that I've approached have claimed traffic engineering, but when I've sat down to do it, there hasn't been any engineering at all. They have adopted the, I'm redistributing my IBGP into the EBGP. And so literally what's happening is they would look at all the /24s that they have, and they go, oh, okay, this link hasn't got quite enough traffic. I'll leak a 24 here. Oh, it's too much. I'll send another 24 there. So if one link breaks, they don't have backup because they don't have a covering aggregate in the backup. So the engineering they're doing is 24s in random directions to try and balance the traffic. Whereas the right way to do it is take your entire aggregate and subdivide and so on and so on. Find out more on Tuesday. So there are a lot of people who seem to be just doing that, redistribute IBGP into EBGP. The people who are doing engineering seem to know what they're doing because they have covering aggregates everywhere, they're subdividing to big chunks, and sometimes you've got small pieces. So those folks, yeah, they're probably announcing 6 or 7 prefixes out of one aggregate. Those folks know what they're doing. It's when you see just 24s appearing, then you really do wonder. I've only met 2 providers And actually one of them is in that list, where I got their management statement, and the engineer said to me, Philip, I'm completely with you. I would love to do what you're doing, but management directive is we announce 24s in case of hijack or DOS attacks and so forth. And what can you do? Nothing. So
we need a tool to deal with these people, the deaggregates.
well, yes, we need a tool, and it's, you know, the vendors have been approached, and I certainly know within Cisco, software has been written. It's never made into iOS, but software has been written to aggregate based on ASPath. So I do origin-based aggregation here. Jeff has seen me do origin, and he's got an ASPath version as well, so his maximum possible aggregation doesn't look as aggressive as mine, which, you know, that's fine, fair enough. I'm looking at what's best possible. But there was a software that was written that did the aggregation based on ASPath. So if you saw the aggregate, covering aggregate, and the sub-prefixes with identical ASPath, then it would drop the sub-prefixes. And this came up in SANOG, I think it was the last SANOG. I think Garab had presented on this particular topic as well, to try and persuade the vendors to introduce a feature. But of course, inside vendor space, there's a worry that ISPs will turn this feature on by default and break traffic engineering. So I don't know what the right answer is. Well, I know what the right answer is, but how do you make all ISPs responsible and do the right thing and so forth?
Okay.
Freddie was going to ask.
Thank you, Philip. Yeah. In the meantime, while Jan can pass his microphone to the back of Freddie, because he's got a question, I'm looking at Christian, but because you mentioned our instability, I think that was one of our risk beacons, right? Yes. So that's on purpose, because we try to measure the propagation of BGP updates.
Hey, that's
so
good. It's
we're
a legitimate
deliberately
entry.
flapping a small prefix to see what's happening there.
Well, you should do better. You're only number 28 in the list.
I think Christian can configure the parameter. Freddie, and then I think I'm gonna close the mics and continue with the next presenter.
Freddie Künstler, Init 7. As you know, I'm in this deaggregation space for a while now, and I'm preaching against it. I just want to share what I just recently learned, and I wasn't aware of this. So some, especially Middle East and Northern African networks, they don't have routing capabilities in Europe where they pick up their transit links. And that is one thing why they cannot aggregate. So what Philip said before, I mean, they announce a /24 here and then another /24 somewhere else and try to balance the links and to avoid packet loss by doing traffic engineering, announcing more specifics. I mean, for the NOC, it's a stress. But if they would have routing capabilities in Europe, so a proper IP router in Europe, they could simply add their lag, their STM64 links together, and the traffic engineering would be a lot easier. So traffic engineering on layer 2 is really a stress, while traffic engineering on layer 3 would be a no-brainer.
Can I comment? Because that's actually where Kasai went this morning a bit, in the importance of local IXPs. If you can manage to switch a lot of traffic locally, you don't have to drag it all the way back from Europe. But that's a side note. And in response to you, of course, we did have this little penalty mechanism for instability that's called route flap dampening, and we're now sort of at the point that we think it's harmful because it breaks quick responses in case of incidents. With that, I think it's time to introduce our next speaker, which is Jan George, working in his role of the Go6 Institute from Slovenia, who's going to talk a bit about the history and purpose of RIPE 554. And as a full disclosure, I have to say that in my role of co-chair of the IPv6 working group, I was also involved in getting this document